Today we are going to be looking at multiplying and dividing rational expressions. Now, we've already talked about finding our restrictions on an original problem. We have also simplified rational expressions. So the good thing to know here is that if you can multiply numbers and multiply variables, and you can simplify those rational expressions, then you can multiply and divide rational expressions. We're just going to put all of this stuff together. Now, before we do, I want to remind you just the basics of multiplying two fractions. When we multiply, all we do is multiply straight across. Numerator times numerator, and denominator times denominator. If we can simplify after we multiply, we do. 2 will go into 14 7 times, and 2 will go into 20 10 times. All right? Now, let me show you something very quickly, because some of you may prefer to do a different method. If you start with the same problem, you may realize in the beginning that 2 goes into 4 2 times. 2 goes into 2 once, 2 goes into 4 twice. Then you multiply. 1 times 7 is 7. And 5 times 2 is 10. It's the same answer. We just simplified in different places. Okay? Either way is all right, whatever you're the most comfortable with. So there are going to be 4 steps to simplifying or to multiplying and dividing our rational expressions. The first step, we always want to find our restrictions first. Okay, just like we did the other day when we learned what restrictions were, what is going to make the denominator equal to 0, because we can't have that. Step 2 is going to be simplify any terms you can. Now again, if you don't want to simplify here at the beginning, it's okay. You can do all your simplification at the end. Then we are going to multiply our numerators and multiply our denominators. That's step 3. And then step 4 is multiply anything left that can be simplified. So let's do an example. All right, so our first example is going to be 8a times 11 over 12a. Now, anytime you have a whole number, I'm going to recommend that you go ahead and put a 1 underneath it, just so that you keep everything in terms of numerators and denominators. Now, we need to find our restrictions first. And I'm going to come over here. I'm always going to put my restrictions over here in red. Alright, so I have an a variable in the denominator right here. I don't have any variables in the denominator on this side. So what could we multiply 12 by to make it equal 0? Well, divide both sides by 12. A would equal 0. So a can't equal 0. That is my restriction. Okay? So there's my restriction. So let's go back to the problem. Step number 2, I'm going to go ahead and simplify any terms that I can. Well, I already see that I have an a on top and I have an a on bottom. Now you may be thinking, but I thought we couldn't cancel across like that. Since we are multiplying, not adding or subtracting, we can. Now, at this point, you may be going, yeah, that's all I see. So we're going to go ahead and go with that assumption. All right, and I'll show you here in a second what else you could have done. So we're going to do equals 8 times 11 is 88. 1 times 12 is 12. Now, both of these are even numbers, so I know at minimum I could divide a 2 into both of them. The reality is I can divide 4 into both of them. So 88 divided by 4 is a 22, and 12 divided by 4 is 3. And here's my answer. So here's my restriction, and here's my answer. And we've multiplied our first 2 rational expressions. Now, some of you may have noticed that you could have gone ahead and divided the 8 and the 12 by 4. If you had done that, you would have gotten a 2 here and a 3 here, and you would have ended up with the same answer as you did here. So again, it doesn't matter if you miss something simplifying in the original problem, it's all right as long as you simplify it in the final answer. Okay, I'm not going to do it both ways on every problem. I'm going to alternate which way I do it because I don't want to confuse anybody. Okay, here's our second example. Let's go ahead and try simplifying. So I've got a b on top and a b cubed on bottom. So I know that 3 minus 1 gives me b squared. I've got a c on bottom and a c squared on top. And I know that 2 minus 1 just gives me a c to the 1. Now I also see that I've got a 5 on bottom and a 15 on top. Well, I know 5 will go into 15 3 times. All right, I've got a 12 on top and an 8 on bottom. We just talked about 4 will go into 12 3 times. 4 will go into 8 2 times. So now let's multiply across. I have 3 times 3c equals 3c. And on the bottom, this whole thing, the 5c has become 1 because 5 went into 5 once and c went into c once. So 1 times 2b squared is 2b squared. And none of that will simplify any further. And I just realized we forgot to do our restrictions. Shame on us. So I'm going to rewrite the original problem again because it gets harder to see it with everything canceled out. It's very important that we remember to do that on the front end. Okay, we have a c in the denominator and a b cubed. So we need to do these one at a time. 5c equals 0, divide both sides by 5. C cannot equal 0. So c can't equal 0. And then I'm going to do the second one. 8b cubed equals 0. Divide both sides by 8. B cubed equals 0. Cubed root of 0 is still 0. So b also cannot equal 0. So here are my restrictions, and here is my answer. All right, let's do another one. All right, here's a third example. We're going to find our restrictions first. Now, we've got 9a times 11 over 12a. The 9a is a whole number, but since we're multiplying fractions, it may be helpful anytime you have a whole number to go ahead and put it over 1 so that you don't get your numerators and denominators confused. So at this point, we have got 1 as a denominator, and we have 12a as a denominator. Well, the 1 does not have a variable with it. Only the 12a does. So we're going to do 12a equals 0. So I'm going to divide both sides by 12. 0 divided by 12 is 0, so a cannot equal 0. That is my restriction. Okay. Now I'm going to reduce anything I can. I have an a up top and an a on bottom. I'm also noticing that I've got 9 on top and 12 on bottom. Now 3 will go into both of those. So 3 will go into 9 3 times. 3 will go into 12 4 times. So now I'm going to multiply straight across. 3 times 11 is 33. And 1 times 4 is 4. There's no a left. This is my final answer, and this is my restriction. Okay. Now don't worry if you don't notice what will reduce in the numbers. This is the last time I'm going to do it both ways, but if we had started out with the 9a over 1 times 11, my pen's not working very well, over 12a, and we notice that the a's will cancel out, but we don't notice anything about the numbers. Well, all that's going to happen is we're going to go 9 times 11 is 99, 1 times 12 is 12, And then I can reduce from here. 3 goes into 99 33 times. 3 goes into 12 4 times. And I still have the same answer. So whichever way you're the more comfortable, you can multiply everything first and then reduce, or you can reduce, multiply, and then reduce anything else if it needs to. All right, let's do another example. All right, so here we have 18b over 5c times 20c to the fifth over 8b to the fourth. So the first thing we're going to do is look at our restrictions. We have two denominators. The first one is 5c. We set it equal to 0. Divide both sides by 5. 0 divided by 5 is 0. So c cannot equal 0. And now I've got a second denominator with a different variable. So 8b to the fourth equals 0. Divide both sides by 8. b to the fourth equals 0 because 0 divided by 8 is 0. Now I am going to take the fourth root of both sides. The fourth root and the exponent of 4 cancel each other out, and the fourth root of 0 is 0. So b cannot equal 0. So we have two restrictions here. The c can't equal 0 and the b can't equal 0. So now we're going to look up here at our example. I have a b here on top. I also have b to the fourth on bottom. So b goes into b one time. B minus 1 leaves me with, 4 minus 1 leaves me with a b cubed. And again, we're just using our exponent rules here. I have c to the fifth up here on top, and I have a c down here on bottom. So I am going to take this c to the 1 on the bottom. I'm going to bring it up here and subtract it. So I get c to the fourth up here on top. Now this is getting a little bit messy, so I'm going to go ahead and simplify at this point. I've got 18 over 5 being multiplied by 20. Okay, come on. 20c to the fourth on top over 8b to the third. Okay. Now at this point, I notice that 5 will go into 20 evenly. 5 goes into 20 4 times. I've got an 8 and an 18. 2 will go into 8 4 times. 2 will go into 18 9 times. Now if you notice, I have a 4 on top and a 4 on bottom. I'm going to go ahead and cancel those out. So I've got 9 times c squared. C to the fourth. And all I've got left on bottom is b cubed. That's a 3 on bottom, sorry. My 3 is not wanting to write. There we go. This is my final answer. Okay? Okay. Here is another example. This one looks a little bit different. We're pulling in our polynomials now, our binomials. We still have to look at our restrictions. 4 equals 4 equals 0. That's not a true statement, so we don't have to worry about that. 3 times x plus 3 equals 0. Let's do this one at a time. This is being multiplied by the binomial, so let's divide by 3. X plus 3 equals 0 divided by 3 is 0. Now I still need to solve for x, so I'm going to subtract the 3 from both sides. X equals negative 3. This is my restriction. X cannot equal negative 3, and that's the only restriction I have for this particular problem. Now, as we look up here at the problem, I have an x plus 3 up here. Well, I also have an x plus 3 down here, so those can cancel. I also see I have a 3 here, and I have a 3 here. I can cancel those. So I am going to go ahead and multiply. This ends up just being an understood 1. So 1 times x minus 6 is x minus 6. Down here, all of this has become an understood 1. 4 times 1 is 4. And this is my final answer. There's nothing left that I can simplify. So here is my answer, and here is my restriction. We'll do one more. Okay, here's my next example. 28 minus 7b over b minus 4 times 1 over b plus 10. I have two different denominators, so I need to set each one of them equal to 0 and solve for the variable. I need to add 4 here to get the b by itself. So b equals positive 4. That's my first restriction. And then I need to do b plus 10 equal to 0 and solve for b. So I'm going to subtract 10 to get the b by itself. b equals negative 10. Here is my second restriction. So here I do have two different restrictions. Now I am going to go through my process. Now, I happen to notice there's nothing in common top and bottom at the moment. But I do see that here in this first numerator, I have a GCF of 7. So I'm going to go ahead and rewrite that. 28 divided by 7 is 4. 7 divided by 7 is 1b. And I just noticed that that's not going to help me because down here I have a positive b and a negative 4. So let's take out a negative 7 when we factor, and I'm going to change those two signs. Alright, so the only thing I adjusted there was instead of taking a positive 7 out of here, I took a negative 7. Okay, and let's go ahead, we're going to rewrite that. We're going to rewrite that as negative 7 over, or times b minus 4. I have changed the position of those. That is all over the denominator, b minus 4, times 1 over b plus 10. Alright, so here I am looking at my problem, and I notice that I've got a b minus 4 here and a b minus 4 there. That's all I see in common, so I'm going to multiply negative 7 times 1 to give me a negative 7. And this is an understood 1 here, so 1 times b plus 10 is b plus 10. So here's my answer, and there are my restrictions. This should be enough to get us started on multiplication, and the next video will be the division.